Okay, let's talk about tipping over and why things fall over and what that has to do with torque. Let's take a box, big, long, tall box, okay? And there's the center of mass of the box. If we look at a force diagram of this box, you have a normal force. Normal force is going to be in the middle, and it's really a bunch of normal forces, little tiny normal forces for each little chunk of the base there. But that normal force pokes right up like that, okay? And mg pokes right down like that. And those two things are in line, okay? So there's nothing making this box want to rotate. But what happens if I push that box a little bit, okay? So if I push that box a little bit and it ends up looking like this, and here's the center of mass, and here's the normal force. Well, think of if you push something with those two forces, and this is not a free body diagram, this is showing where the actual forces are. If you push something with that kind of relationship, it's going to make it twist. So what happens is this is going to make it twist this way. And what it does is it comes back to its neutral position. If we push it a little further, push a little forward, maybe I'll draw it bigger here. Okay, so I just enlarged it quite a bit. If I push it a little further, and there's the center of mass, well, there's mg straight down. Here's the normal force straight up. And if you push something like that, try that. Take something and push like this on it. It makes it twist this way. So that will make it tip or fall. Okay? So really the rule for tipping is if the center of mass is, we'll say, inside the base, okay? So I can tip this a certain amount, and remember what I had before when the mg was over here and the normal force was over here, it went back. We say that's kind of stable, okay? It went back. So if I give it a little push this way, it takes a lot to get the mg to go past the base, to go outside the base. The center of mass, I actually have to lift it up a little bit, right? Anytime you tip this thing, the center of mass is going to rise a little bit. So it's only after the center of mass passes the base here that it will tip over. If I don't push it far enough to do that, it'll fall back, okay? So tipping is when center of mass moves beyond the base, whatever that base is. So as long as the center of mass is somewhere between here and here, because there's the base of this object, as long as the center of mass is somewhere between there and there, it will fall back, okay? If I move the center of mass outside, it tips. And clearly, if you have a really narrow base, that makes it easier to tip over. If we think of people and we think of, we talk about people being stable or hard to knock over or steady, if they have a low center of mass, but it really is, there is something to do with the height of the center of mass, but it's really more where that center of mass is relative to the base. So let's talk about that low center of mass concept. What if we had a box that looked like this? Okay? And remember, for it to tip over, the center of mass has to go beyond the base. Well, to make this center of mass go over here, I have to actually kind of lift it up. The wider this thing is and the lower the center of mass is, the more, if I take this thing and try to tip it, I wouldn't really call it tipping it, but I try to move it so it falls over this way, I have to move the center of mass way up here. I have to actually lift it. So a low center of mass makes it a little harder to tip. A wider base makes it harder to tip. So those are the things, if you're standing and you're playing football and you got your feet together like that, your center of mass is really easy to move beyond the base. Somebody hits you just a little bit, you're going to fall over, right? So what do? One thing you do is you spread your legs a little bit, and now it's harder to move this past the center of mass. In fact, it does. You don't see it as much on long, thin things, but You do have to lift the center of mass just as you had to here. It doesn't take that much to do it. Well, what if you bend your knees and you spread your legs out a little bit? You can't draw that very well, but here, now the center of mass is much lower, and to get up over that outside the base, you actually have to lift it up and apply a lot of force. So it's a combination. That's what they talk about, lowering your center of mass. Really broaden your base, lower your center of mass, it makes it harder to tip. Okay? And if we think, now let's put it in the context of torque. Okay? If I have that box again, random box, picking a different color. If I have that random box here, and I'll just have it as like this. Okay? What I have to do is, if I take that as my point of rotation, thinking about torque, okay? If I lift this box just a little bit, okay, mg is going to be in this direction, and so there will be a net torque in this direction. I'm going to call it the counterclockwise direction. So if I lift this up just a little bit, it's going to apply a torque to make it go back down. If I lift it up a lot, and I get it out so the center of mass is over here, I didn't draw it very well. If that's my point of rotation, I've got R, F, I've got a torque in that direction. So it will make it tip. So if the torque makes it go back towards its normal position, we say it's stable. If the torque makes it go outside, we say it's unstable. It's a lot more technical than that, but that's basically how torque makes things tip over. Now let's look at this beaker that I used here. Okay, the center of mass of that beaker is somewhere, it's got to be somewhere between these 2 points, right? Because that's the base. Now, if I just put that beaker on its edge, and it's got a curved edge, let me show that again. It's got a curved edge here, right? If I just put that thing on its edge, it's going to fall over. I can't get it to stand up straight, right? Because the base is this infinitesimally small edge of part of the flask, right? But what I did is I put it on salt, and then I blew the salt away. And what happened is, yeah, there were other granules over here. When I blew those away, there's no reason for them to stay there. But these ones, when I put that beaker down on that, it kind of pinned them in there. And so it did a couple of things. It supported the beaker, and it broadened the base. The base went from being right there to this, I'm sorry, I've got a big reflection. The base went from being right at this one point to this broader thing. It was only a few grains of salt wide, but even so, that was enough so it was somewhat stable. So little breezes, and I've got my my fan up there heating the room. It's blowing. The wind didn't blow it over. It wasn't enough wind to blow it over because it was somewhat stable there. Okay? And again, when I blew the salt away, the grains that were held down by the beaker, that there was some friction there, they didn't move. So that base remained. And as you saw, it only took a few grains of salt. A few grains of salt placed properly, and they kind of self-placed when I jammed it down, were enough to support that thing. So that's the concept of tipping and the concept of how torque makes something tip over or makes it go back to its original base.